Welcome to a new video on my GNU/Linux and USB tutorials. Today I want to show you how to implement control transfers on our Atmega32U4 USB device and in Python on the host. So let's start. So I've already programmed a little Atmega32U4 USB device, but it does nothing but answers correctly to the USB enumeration. And today I want to add some functionality by controlling these 2-digit 7-segment display over control transfers. But first, let's talk a little bit about the theory behind control transfers. So a control transfer normally uses 3 or 2 stages. So the first stage is the stage where the setup package is sent. Then we have an optional data phase, and at the end we have a handshake. So let's take a closer look how the setup package looks like. So here we have it. The setup package is 8 bytes in size. The first byte is called BM request type, and this contains the direction. So if it's an in or an out transfer, 0 for out, 1 for in. Then we have the type. So 0 is the standard type, and the standard type is, for example, used for USB enumeration. So if the host PC is getting the descriptors or writing the address to the device, this is a standard setup package. And what we are going to use is this vendor type here, because we will implement vendor-specific control transfers. And down here we have the who should receive this package. So we will use 0 for device, but it also could be 1 for interface or 2 for endpoint. Then the next byte is the request, request. And this is the number of the request. We will define our own numbers as we're using vendor-specific requests. Then we have 2 bytes for a value, 2 bytes for an index, and 2 bytes for a length. And the length field is important because if this is 0, the device knows, okay, there is no data phase, and if the value is bigger than 0, we know there is a data phase coming after the setup package. So now let's take a look at the requests I want to implement. So I want to implement one request to write the value to my 2-digit 7-segment display, and another request to read back the value displayed by the 7-segment display. So here is the request I want to use to set the value. So the request type here will be 40, which is just direction out and vendor specific request. The request number will be 1 for setting the value, and then in the value field, the lower byte will contain the value which should be displayed by the 7-segment display. The index is I don't care, here I won't use it, and the length will be 0. This means there is no additional data phase after the setup package. And then we will have to acknowledge and finish this with a handshake, and that's it. And the second request I want to use is for reading back the value of the 7-segment display. So here it's also vendor specific, and the direction is in this time. I will use request number 2 here. Index and value is I don't care, here I won't use it. And here length is the number of bytes which should be sent back to the PC. It has to be at least 1, but it can be a bigger value too. And the data which will be sent back is the first byte is always the value of the 7-segment display, and then the other bytes are just are don't cares, but for example I want to show you how to transfer larger amount of data than 8 bytes, and after all 8 bytes, which is the size of m.0 on our device, we will send or the PC will send a 0 length package to acknowledge it, and at the end we have the finishing handshake, and that's it. Okay, so now let's try to implement this. I'm already in my USB tutorials folder with the firmware for my Atmega32 USB device. Let's check out main.c, because in here I've already added some code to display values on the 7-segment display. So everything is already done for us. The only thing we have to do is we have to store the value we want to display in this display variable here. And I have defined this display variable as an extern here in this header file, in the library's header file, and we can find this in the source file. So if we go up here you see we have this display variable here. Okay, so what happens when a new setup package arrives? The microcontroller will jump into this interrupt service routine and it will check for which endpoint the package is. In case it's for endpoint 0, which is the only endpoint we have now, it will set the multiplexer for sending to endpoint 0. It will check if we have received a setup package, and if so, it will call this USB endpoint 0 setup package, so which is implemented down here. So here you can see we have all the values for the setup package already set up here. Then we have the descriptors. And now down here, it's checking if we have a standard request, because if it's a standard request, it will reply, or it will check now the B request value, and then it will perform the various stages of the USB enumeration. And if it's not a standard request, it will send a stall response to signalize to the PC, hey, I don't support this request. But we will add a new option here. So else if BM request type and 16 hexadecimal is equal to 40. So this means we have a vendor specific request. Then we will implement our function now. So let's do a switch B request. So in case it's 0, it's the order for set new value to 7 segment display. In case it's 2 hexadecimal, it's return displayed value. And if it's another value, we don't support this, so I can just copy these two lines here. We will send this stall request back to signalize, hey, we haven't implemented these functions here. Okay, so first let's go a little bit up here, because one important step I forgot to mention, or was it back down here? Yeah, so here we are reading the setup package out of the buffer, out of the FIFO of endpoint 0. This is done here, and we are storing it in these variables here, so we already have them available down here, and here we are acknowledging the received setup package. So let's go back, let's go down here. So all we have to do here is we have to say set the display variable to the lower byte of the value, and then we have to send the handshake, and we have already done this, for example, up here in the set address phase. So I will copy these two lines here, and I will paste them in here. So what we're doing here is we are sending the acknowledge we have received the package correctly, and then we are waiting for the response from the, or we are waiting for the serial length package to be sent, and this is the complete handshake which is needed here. Okay, and now let's say we want to return the displayed value. So the request number is 2, so let's return this. So the first thing we will do is we write the display value into the FIFO for the data which will be sent back to the PC. And then we will start an endless loop, or we will start a for loop. And this for loop will, so in the length variable we have the desired amounts of frames which should be, or bytes which should be sent back to the PC. So in case we have here a 10, for example, we will send back 10 bytes. So the first byte is always the value of the display, 7 segment display. And for the other values, I will just send back this I variable here, because this don't care. And for sending back, we can use this code here. So let me copy these lines here, these 11 lines here. That was a little bit too much. Okay, so what we're doing here is, in case I modulo our endpoints FIFO size, which is 8, is 0, we can send the data, and then we are waiting for the acknowledgement of the host. But it could be, for example, if we want to receive 10 bytes, the length modulo 8 is 2 and not 0, so we have to send the remaining bytes back, and this is what we are doing here. And this at the end here is we are finishing the handshake, and that's it. Okay, so this should be the code to control the 7-segment display here. So let's try to build it. Okay, an error here expected before else. Okay, let me look at this, which line it was. Okay, 287. Okay, wrong file. Yeah, I forgot to close the brace for the switch case here, and this should be the error. Yeah, now we can compile it. And now let's flash it to our microcontroller. I have to give it my password. Okay. Okay, so now we can see the default value of the 7-segment display is 0, and now we want to test these control transfers from our host PC. And therefore I will be using Python, and I will need the following package, which I can install with pip, and I want to install pyusb. So I need this package for USB communication over Python, but I already have it installed, so let me start up Python here. Okay, and now I will import USB core, and I will use the function find, yeah, and I have to give it the product ID and the device ID, and I always forgot the product ID, so let's check them with SUSB. Okay, this is the vendor ID, so the product ID is 1 and the vendor ID is this here. So I can close this window. Okay, we haven't found a device. Give me a second, I will troubleshoot for a second. Okay, so the error was using the false arguments here, so it's ID vendor and ID product. And now if we check device, we see we have a device here on bus 3, address 7. And now we can execute a control transfer. So the arguments here, the first is the BM request type, then the B request field, the value, let's use 12, and the index, which is I don't care, and the length, which is 0 here. And you can see now I'm displaying 12 here. So writing works. Maybe let's do one more write. CO, yeah, it's working too. So writing works. Now let's try reading. So here I have to pass the request type C0. The request will be 2. The value is I don't care, the index is I don't care, and I want to read 1 byte. And here I'm getting 192, and if I convert this to a hexadecimal value, you see it's C0, so this works. And if I try to read 10 bytes, for example, yeah, you will see the first one is always the displayed value, and the other values are our I variable counting up from 1 to 9 here. And maybe let's do something crazy. So let's read back 4 kilobytes here. And you can see this also works. Or let's do this again without passing it on the screen. And the first yeah, the first variable is always the displayed value. Okay, cool. So we have implemented some functionality to our USB device by using control transfers. In my next video, I will implement this functionality by using libusb 1.0 in C. But I hope you've enjoyed the video and learned something. In case you want to support my channel, you can buy me a coffee on buymeacoffee.com/Johannes for Linux. So that's it for today. Thanks for watching and goodbye.